Hi gang, so this is our challenge problems. This is where honors differentiates from regular. So we are going to call this the challenge zone. The challenge zone. Okay, so you're going to want to know how to do these problems. We have done a lot of this first one. The length of side AB is twice the length of AC. The perimeter of the triangle is 96. What's the length of AB? What's the length of this side? Okay, we've done a lot with perimeter. We know perimeter is the distance around the triangle. We haven't done a lot of this, so we're going to take a look at this. AB is twice the length of AC. AB is twice the length of AC. AC is 2x minus 1. If AC were 10, you would tell me that AB, you would double it and say, oh, it's 20 because it's twice the length. If AB was 5, you would double it and say it's twice the length, so it would be 10. I don't know the number value of AC, but I do know the variable value. I know that this is 2x minus 1, and I just need to double it. Now, I could have said 4x minus 2. I could have just doubled it in my head that way. It doesn't matter. I am going to go ahead and hippity-hoppity and distribute this just to make it a little easier. So it's 4x minus 2. So the length of AC is 4x minus 2. So I'm going to actually highlight that. The length of AC is this, and the length of BC is that. Can I figure out the length of AB? Absolutely. If I walk around the outside edges, what does it add up to? 96. Let's walk. Let's go 2x minus 1 plus 3x plus 4x minus 2. I know that when I do that, it adds up to 96 units. Pause your video and see if you can do that without having me work it. I'm going to keep working it. I'm going to look for those like terms. I do notice some numbers here. I notice -1 and -2. I can put those together. And I also notice, and I'm going to highlight them. Actually, I'm going to use a different color. I notice some other things that will go together. 2x, 3x, and 4x. I'm going to combine like terms in one step. 2 plus 3 is 5. 5 plus 4 is 9. So that means I have 9 x's. Number-wise, I have -1 and -2. I can put those together and get -3 equals 96. I'm going to keep going. I'm going to add 3 to both sides. That'll give me 9x equals 99. And I'm going to divide by 9 on both sides. And I'm going to get that x equals 11. And that's my answer, right? I can stop. No, because what the question was is, what is the length of AB? What is the length of AB? The question was not what is x, it's what's the length. Okay, AB. The length of AB is 4x minus 2. I now know that x is 11. I know the x value is 11 minus 2. That means it is 44 minus 2, which is 42. So that means side AB equals 42 units. I'm just going to put 42. Know how to work that one. You are going to see that one again. All right. Represent this compound inequality with a number line. Now, we haven't really done much of this. So let's see if we can do it. A compound inequality means you have two scenarios. You have -2 is less than x, but you also have that x is less than 2. You have to take both of these scenarios and create one number line for them. So I'm going to take the first one, -2 is less than x, and then the other scenario is that x is less than 2. Now, you know me, I don't like to do this way. I like to read it the other way. So if I were to rewrite it, I would put x and negative 2. It's pointing to the negative 2, so I'm going to make sure it points to the negative 2. Okay, so this reads, I'm going to put 2 and negative 2. X is bigger than negative 2, so I'm going to circle the negative 2. I'm not going to color it in because it doesn't have the equal sign. X is bigger than negative 2 is going to go this way. Okay, that's easy enough. Now the other one, it actually is already going the right way. So I'm going to put 0, I'm going to put 2, and negative 2. It says that x is less than 2, so I'm going to circle the 2. I'm not going to shade it in, but it says it's less than, it's pointing this way. Now here's what a compound inequality does. It takes these two inequalities and puts them on the same number line. So we're going to come down here, and we are going to draw one number line. We're going to put a 0 because they both have a 0. They both have a negative 2, so we're going to put a negative 2 and a positive 2. Do you see where these lines, if I were to put them on top of each other, where they overlap? What I see is if I just look to right here at negative 2, I would have an open circle because the top line doesn't include it. The bottom line does. So I need to pay respect to the one that doesn't include it. The 2 and the negative 2, or I'm sorry, the 2 and the 2, when I smush them together, there's going to be a hole at 2. And what's going to happen is everything in the middle here is going to be included from negative 2 to 2. All this outside stuff is only on the red graph up here. And over here, it's only on the blue graph down here. So I need to do, if I were to merge those, where do I see purple? Where do they overlap? Which is right here in the middle. That is how you do a compound graph. Watch out for those inequality signs. When is it equal? What if I had done this? What if I had put a line under that one? Ooh, okay, so that means this would have had a line. This would have had a line. So it would have been x is greater than or equal to negative 2. So I would have colored that in. Now I would come down here and this one would have been colored in, but this one would still be open. If you want more practice on compound inequalities, let me know. All right, LA Fitness offers spinning classes for $12.50 per class. Lauren finds an online deal that offers a discount on the spin classes and a pair of spinning shoes at a one-time cost of $146.77. If the shoes cost $46.77, including tax, and the deal offers 2 free spin classes with it, how many spin classes total will Lauren be able to attend with this deal? Okay, LA Fitness has offered spin classes for, I'm going to offer it, or highlight it. The spin classes are $12.50 each. She is a one-time cost. I'm going to highlight that. And her shoes are $46.77, including tax. Oh, and we're getting 2 free spin classes with it. I'm just going to put 2 free spin. Let's see what we can do. Because the question is, how many spin classes total will Lauren be able to attend with this deal? So let's take the $12.50 for each spin class. So let's let x equal the spin class. X is what we're trying to find out. How many spin classes can she attend? They're $12.50 each, right? She's spending money also on her $46.77 shoes. And this is going to add up to $146.77. Okay, so let's see what happens. Let's take 146. Oh, okay. Thought my calculator died. I should probably show y'all what I'm doing first. Let's subtract 46.77. 46.77. 146.77. Oh. Minus 46.77. You can probably see it's, oh, hello, it should have been 100. Oh my goodness, 146.77 minus 46.77 is 100. There we go, it's 100. Okay, so this over here is 100. That zeroes out and we have 1250 x equals 100. I'm just going to keep solving here. I'm going to divide both sides by 1250 because it's 1250 for each spin class. So I'm going to take 100, divide it by 1250, and it's 8. All right, so that means that x equals 8. Now, I want you to think about what this is saying. This is what the classes are. They're $12.50 a class. But you get this deal. If you buy the shoes and you get the 2 free spin classes with it for $146.77, how many spin classes total is Lauren going to get with this deal? Well, she's already got 2 free classes, right? And with this deal, she's basically paying for 8 more classes, 8 more. So with the deal, she's getting 10 classes. And what else? Shoes. She's getting those awesome shoes. All right, that's a challenge question. You have to come up with that equation all on your own. All right, here we go. Mario is saving $90 to buy a new hoverboard. His first option is to put away $25 and then save $5 a week. The second option is to put away $100 initially and save $8 per week. Oh, so not as much initially, but he's saving a little more per week. After how many weeks would Mario save the same amount using the either option? Which plan reaches his goal the fastest? All right, his goal is to raise $90. Let's just think about this. Let's do option 1, and we'll do option 2. Let's take option 1. He's going to put $25 in the bank, and then he's going to save $5 every week. We'll use x equals the week. When will this equal $90? How long is it going to take him to get to 90? Well, let's see. Let's subtract 25. Subtract 25. So that's 5x equals 65. But let's do 90 minus 25 is 65. And then let's divide both sides by 5. X equals 13, but let's divide that by 5. 13. So that means for option 1, it would take him 13 weeks. So this would take 13 weeks to raise his money. Now let's look at option 2. Option 2, we're only putting away $10, but we're going to save $8 per week. When will that equal 90? All right, well, here we go. I'm going to subtract 10 from both sides. So that's going to be 8x equals 80. I'm going to divide both sides by 8. And that's going to give me x equals 10. That means option 2, even though he starts off with less, it's only going to take him 10 weeks total to get to that plan. So which plan is better? Probably option 2. Option 2 gets him there faster. So option 2 is the faster one. Okay, so let's look at the next one. After how many weeks would Mario save the same amount using either option? Well, to figure that out, I'm going to take my 2 equations. I'm going to do that in a different color so we can see it a little better. Or maybe not, because I can't find my pen. I'm going to take 25 plus 5x, and I want to know when does it equal 10 plus 8x? When are the plans exactly the same? So here we go. I'm going to subtract 25, subtract 25. That's going to give me 5x equals negative 15 plus 8x. I'm going to move 8x over. Negative 3x equals negative 15. I'm going to divide both sides by negative 3. And I'm going to get x equals a positive 5. So, in 5 weeks, they're exactly the same. But at week 10, option 2 becomes better. I'm sorry, at week 5 weeks, they're equal. After 5 weeks, it doesn't matter which one you put in. Option 2 is going to start making more money than option 3. Option 2. Oh my gosh, I can't say it right. 13 weeks. All right, so another way, and some of you may have thought to do this way, you could have just made you a little T-bar. And you could have said, well, at week 1, how much money would I have? At week 2, how much money would I have? And you would have seen that at week 5, that's when they're both the same. But then at week 6, option 2 is better because you get more money in option 2. Just kind of a way to look at it. So that's the challenge zone. That's our challenge problems. Be sure you understand those for our test.